Everyone, let's solve some Leetcode today. So today we have Leetcode 90, that is subsets 2 problem. We have already solved the subsets 1 problem in which we were given an integer array of unique elements and we had to figure out the subset for it. Here in this problem we have been given an integer array of nums. The only difference is that the elements can be duplicate. So we can have duplicate elements in the array, and now we have to return the possible subsets of this entire array. Here we can see we have duplicate elements in the nums and we are only supposed to return the unique subsets from this particular array. Let us understand how to solve this problem with the help of an example. Here we have 1, 2, 2 and 2 in the nums array, and we will try to create its subsets. The indices for these elements is 0, 1, 2 and 3. So we start the 0th index and we will decide whether we want to take this element or not. If we decide to take this element, then in the subset we will have 1, and now we will reach the first index. If we decide that we don't want to take this element, the subset will stay empty and we will reach the first index also. Now we are done with the possibilities of this 1. Now we are at this element, so we will decide whether we want to take 2 or not. If we decide to take 2 in the subset, then we will have subset like this 1, 2, and then we will reach the index number 2 for this particular one. If we decide that we do not want 2, then we will again have just 1 in the subset here in this branch, and we will reach the second index. Similarly, on this branch also we have an option. We can either take the element 2 or we can decide we don't want it. So if we decide to take 2, then the subset will contain 2 and then we will reach at the second index. If we decide that we don't want it, then the subset will again contain empty, and then we will start considering the element at index 2. So this 2 is actually element and this 2 is actually index. So here we have element 2 at index 2. Don't confuse it. I have colored the indexes in blue. So now we are done with the possibilities of this element and this element. Now we are dealing with this particular 2. So we can decide whether we want to take this element 2. So if I decide to take it, I will be having 1, 2, 2 in this branch of my subset, and then I will reach the index number 3. If I decide that I don't want it, then I will again just have 1, 2. And then I will reach the third index. Now if I decide to take the element at index 2, then here in this branch I will have 1, 2 in my subset. Otherwise, if I don't decide to take it, I will only have 1 in my subset, and then I will reach 3 here. In this branch also, if I decide to take 2, I will have 2, 2 in my subset. If I don't take it, I will only have 2 in my subset, and then I will reach the third index. Now here also, if I decide to take 2, I will have 2 in my subset, and if I don't decide to take 2, I will have an empty subset, and then I will reach the index 3 for all these branches. Now here you need to notice something. So first of all, we have a subset here which is 1, 2, and now we again have this subset here 1, 2. So basically there are two branches where we got the same subset, and this will propagate till the end. So we will get 2 copies of this subset. So why did this happen, right? That is the question. And the reason why it happens is very simple, really. So we started with this 0th index. We decided whether we want to take the 1 or not. So we made our choice that okay, we want 1. Now we went this direction. Now we are dealing with this particular element 2 in this place. So what we are deciding at this particular place is that whether we want to take the element at index 1 or not in the subset. And in this branch we are taking it, and in this branch we are not taking it. So here I said that okay, I want the element at index 1, that's why I have 1, 2 in my subset. But in this branch I said I don't want it, that's why I have only 1 in my subset. Now when we go further in this branch, we reach the index 2. Now we are deciding here whether we want to take this 2 or not. Now I decide that I want to take this 2, and then we again get 1, 2. So what's really happening is that this element 1 is actually making a subset with this 2 at this position, and then it is making a subset with this 2 at this particular position. So yes, if you really look at it properly, you will realize that the 1 here is actually the 0th index element, and the 2 here is actually the first index element, and here the 1 is actually 0th index and the 2 is actually second index element. So yes, from the point of indices, these two subsets are different, but when you actually look at them, elements are actually the same, 1, 2 and 1, 2, and that is why we are calling them duplicate subset. Simply because the elements are same, even though the index wise they are different subsets. And guess what, we still have another 2 here. So from this third branch we will end up creating more and more and more. So basically this one will create a subset with this 2 also. So we will have again another copy of 1, 2. In the same way, this particular subset 1, 2 will end up creating subset with this 2 and this 2 separately. It means that we will have 1, 2, 2 and 1, 2, 2 at 2 places. We will have a copy of this subset also, and that is why we will end up having many duplicates. So the question is, how do we avoid duplicates? And it's simple guys, the reason we are creating duplicates is because this particular element first create a subset with this element and then create a subset with this element in another branch. And it is okay if this particular element was something else like 3, then we would get 1 comma 3 as a subset in other branch, which is a unique element, right? Which is a unique subset. It's not a duplicate. But the only issue is that we don't have a 3 here. We have 2. It means that we end up repeating 1 comma 2 and 1 comma 2 in different branches. And if we look at our decision tree, we realize that once we actually take this 1 comma 2 and we said that okay, I do not want this particular 2 in this branch, then later on I actually encounter this particular 2 and I end up creating this particular 1 comma 2 again. So now the way to avoid this thing is to make sure that when we are saying I do not want this particular element 2 in this particular branch, I actually skip all these 2. I skip this 2, I skip this one, I skip this one, and then I actually go to this branch. Otherwise, I will simply keep creating duplicate subset. So suppose we had 3 here, we will skip this, and this, and then we will actually take this index, that is 4th index. So we will actually have a choice on the index number 4th here, not 2. And then we will actually have 1 comma 3 here or 1 here. Now we have actually avoided the duplicate easily. If we decide we do not want to take this element, then we skip all these elements in this branch. Now similarly, here we are taking 1 comma 2. We are at the index 2. So you can see that this index 2 was not left out. This index 2 was taken care of in this particular branch. Now here also, what we are saying is that if I decide to take this 2 here in this particular place, in this type, then in this side I must remove or I must skip all the remaining 2's from here to here. Okay, otherwise I will create duplicate of 1 comma 2 comma 2. This thing will be duplicated on this branch. And that is how you find the unique subset in this question. Once you have taken an element A in this side, you will make sure that you skip all the A's. Okay, all the elements that are equal to A will be skipped in this branch. That's how you avoid duplicates in your subset. Now let's go through the code also. So here I am creating a result array which will actually contain all the unique subsets, and here I am actually having a subset array which will contain the intermediate subset results. And here we have the DFS. In this I am passing the source node, which is the index of the elements of nums array, and here I have a base case. In case the source node ever becomes greater than or equal to the length of the nums, we know we have created one of the possible subsets from one of the branches of the tree. So we will simply copy that subset, make a copy of it, and we will append it in the rest. The reason we are making copy of this subset is because this subset array is actually going to change throughout the code execution because it is passed by reference, not value. So we are making a copy of the subset and appending it in the array, and then we simply return because there are no more elements in the nums array to deal with. Now if this base condition does not hit, first we make a choice of having the current element in the subset. That's why we are adding the nums of source node, calling the DFS on the next index. So the left sides of branches everywhere, so this branch, and then this branch also. So all the left side branches are actually controlled by that particular code. Now once we complete all those branches, we will now deal with the branches where we decide that we don't want to take this particular element in the subset. So here I am just popping the element, the current element in the subset. Here I am avoiding the duplicate. So here in the while loop I am saying that if the source node plus 1 is less than the length of the nums array, so that we do not go out of bound of the array, and if the current element at this particular index or source node is actually equal to the next element, we simply increase the source node by 1. We are simply skipping this element, and once we do this, once we actually reach a unique element or a new element, we skip all the duplicates of this particular element. We will then call the DFS on source node plus 1, and here our function actually ends. So once this entire function runs, we will have result in our res array. Now here we are sorting the nums first of all, and the reason we sort the nums is because we want all these duplicate elements to be together. Otherwise if they are not together, then I will not be able to skip them, eventually leading to duplicate subsets or wrong answer. So that's why we are sorting it here. Then I'm simply calling the DFS at index 0 of this nums array, and after this happens, we know that we will have a result in the res, so we will simply return it. Now in case you are having any issues in understanding how the DFS works, please look at the subsets 1 problem that I have made a video on already. That video will actually tell you how this particular DFS works with complete flow diagram of recursion calls also. So I highly recommend you to please check out that video if you have any trouble in understanding how DFS or recursion works. So now let us run it and see what happens. So yeah, it runs in 0 milliseconds and beats 100% of the solutions on Leetcode. That's great, right? I mean, yeah, you cannot trust this number definitely, but I believe it's a pretty efficient solution. So now let us look at the time and space complexity for this solution. So in this question, we were supposed to return all the subsets by generating them. And that is why the time complexity is order of 2 raised to the power n. Because there are 2 raised to the power n subsets for any array. And it means to create all these 2 raised to the power n subsets, we call the DFS recursively 2 raised to the power n times, and that's why the running time or the time complexity is 2 raised to the power n. Now in terms of space complexity, we have n multiplied by 2 raised to the power n, and the reason is very simple. So we are talking about our output result. So res actually contains how many elements? 2 raised to the power n elements, because we know that we have 2 raised to the power n subsets for an array. So yes, this will contain 2 raised to the power n elements for sure. So we will have array like this, and it will have 2 raised to the power n arrays. Now, how many elements do you think is existing in each of these arrays? Some arrays will have 1 element, some arrays will have 2 elements, some arrays will have 3 elements, some arrays can have 4 elements. So different arrays will have different number of elements, and that's why we will take the average number of elements per array. So we will sum them up and we will find the average, and the average number of elements per array will be n divided by 2. So it means we are storing n by 2 elements 2 raised to the power n times in this particular array. So you can say that res stores n by 2 multiplied by 2 raised to the power n elements in total. And so the space complexity will become order of n by 2 multiplied by 2 raised to the power n, because that is the amount of storage we are taking. But we know that in space complexity, or basically bigger complexities, we do not deal with constants. And here the constant is 1 by 2 multiplied by n multiplied by 2 raised to the power n, right? So we can simply drop this constant because it's a big O notation. So we will simply write n multiplied by 2 raised to the power n, and that's how you calculate the space complexity for this solution. So yeah, like the video, subscribe the channel, and if you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then just let me know in the comments. Now we will meet in the next video. Till then, bye.